Hi, I'm Dr. Alexander NGENZI from University of Rwanda College of Science and Technology, Department of Computer and Software Engineering. Now we are going to move to the next part of today's lectures, which is going to be the RADIX-2 and RADIX-4, as I mentioned from the introduction of this chapter. And the outlines. So the RADIX-2 means having 2 inputs and 2 outputs. And this is done in case of just having a very reduced number of computations. Suppose if we have 2 signals, you want to the 2 signals are summated or decimated or divided into small numbers of fractions from input side to the output side, then that is what we call RADIX-2. And in this case, n is going to be 2 power r. The other side we used to have n, small n, having 2r, but in this case the big N is going to have 2 power r. That is number 1. So for 2 disseminated sequence of signals. Also, we can have also the RADIX-4, whereby we are going to have the 4 inputs and 4 outputs. In this case n is going to be the power of 4. So all these numbers, if we want to get efficient output, the more the numbers, the more efficient you get. So the 4 points, the RADIX-4 FFT is going to be better than RADIX-2. So you understand, the more you increase the number, the more you get the efficiency of the output. So this is what we are going to discuss today and see how it is done. So let us now move to the explanation and see how it is computed. So let us begin with our RADIX-4, RADIX-2 and RADIX-4. RADIX-2 and RADIX-4 FFT algorithm. FFT. So we said that the RADIX-2 we said that RADIX-2 is where we have 2 inputs and 2 outputs of n times of DFT. So we have to divide n times of DFT times, and remember with the power of course, if there are 2 signals, 2 inputs and output, we have to get the power of 2. In this case, n is going to be 2 r as our RADIX-2. So in this algorithm. So, and this means that we are we have decimated 2 signals, from n sequence, from the ranks of n over 2, as we used n over 2 point, the other one that we used to have. So in this case, you can see everything has changed when we bring this concept of RADIX-2 or RADIX-4. And the more, as I said, the more efficiency is observed when you increase the number of of more radix numbers. If you increase the number of radix suffixes or the radix numbers when these are increased. So the more this side is increased, the more efficiency you can get. So that's what I was explaining. And also, this is for RADIX-2. So the RADIX-4, in this case, RADIX-4, it is where we said we have the input signals or input variables are 4 variables. And also you can have the four outputs. So you can have these 2 points. And in this case, the DFT, the n is going to be the power of 2 or of 4, power of 4. So you can have, for example, n is equal to, for example, in this case, for example, this is very important. So suppose if you have numbers ranging, for example, if you have n ranging from 0, 1, if it is a 4, for example, 2, then it will end up to 3, for example. If it is n is equal to 4, then you can have such kind of value in this case. So let us just go in deep and say how, for example, if we want to bring the odd and the even values. Remember, whatever you do for the even values is going to be the multiple of 2, that is a multiple of 2 numbers, and for the odd is going to be the plus 1 from the original values. Even numbers, we are going to have, for example, a series of values for the even indexed numbers, for example, the x of 2m, for example, which is going to range from, for example, from any value, the x0, x1, x2, and so on and so forth, up to the x of big N minus 2. So suppose if you have such kind of values, and for this is the even, and for the odd numbers, the odd number or the odd sample is going to be x of 2m plus 1, which is going to be given by okay, the other one was supposed to be, no, this one is not there. It should be this one. It should be x of 0. This is x of 1, x of 3, and so on, and up to the x of n minus 1. So the other one is n minus 1, showing the odd values. Remember, this is even up to this value. So, and this is odd until it reaches the other value. So the x1 doesn't belong to the upper because it is in the odd number. And then you can combine the two resultants or the two signals as the whole sequence. So you can have the x of 2m plus x of 2m plus 1, which is going to be all the combination of this. So it's going, if you can combine them, it's the other one, so you can combine them at the same time. So it can be x of 0, then you bring also this one, x of 1, x of 2, x of 3, up to this one, up to x of big N minus 2 plus N minus 1. So in this case, So it's like I have summarized it. Otherwise, I could have brought this one and add to this, but this one is a summary of these values. So you can combine them, then it becomes a single signal. So that is a RADIX number, RADIX-2, where we have two inputs and two outputs. So now we can move to 4 points, RADIX-4. So now let us discuss about the RADIX-4, whereby we have 4 inputs and 4 outputs, and whereby n is equal to 4R in this case. So we are going to see the examples of either the RADIX-2 and the RADIX-4. Of course, they are almost similar, but the difference being that for the RADIX-2, there are 2 inputs and 2 outputs. Whereas for the RADIX-4, it is for 4 inputs and 4 outputs. So the rest is the same because we use the same formula, we use the same computations, and also replacing even the n, remember the big N. So we are going to see the examples of each and every type. So beginning with examples on RADIX-2. So suppose if you have, for example, n is equal to 4. So you are going to compute the n at 4. And we're having our formula whereby you have this formula. It is a normal formula that you all know. For example, the n minus 1, in this case, of x of n, and then w n nk, in this case, for example. So you are going to substitute where there is a big N. So where do you find big N? Here and there. So it's going to be x of k in this side. It's going to be summation of from n is equal to 0 to 3, because it is 4 minus 1. So remember, we are using n is equal to 4 to x of n in this case, and we have w of 4 in this case, and nk. So we have substituted our n, which is equal to 4. So if we begin for n values where it begins with n equals 0 up to n value 1, 2, and 3 to these values, for example, then you can substitute these numbers whereby small n, you will be having, for example, at w is equal to 0, at w4, 0, w4, 1, w4, 2, and w4, 3. So you calculate one by one. So you get all these values in this case. So it is very easy to calculate at these points. Huh? Then you put your signal, and you substitute into your value, and then you get your answer. You remember when we said W4 at 0 is equal to W4 at 4, for example. And this is always 1, for example. This is the answer we always get. And if, for example, you have an 8 point, for example, in this case, you are going to have then W at W41 is going to be W49, for example, if we have 9 here. And this is going to be, for example, negative J. This is to remind you during your calculations, how do you make it? So, for example, W42 is going to be the same as W46. And this is nothing but -1 in this case. And also W43 is going to be J. So you remember when we are just distributing these values, you can see that it is, for example, if you say, for example, Wn of nk, for example, if you supply for any values, you get 1, negative J, -1, and J in this case. So if you sum up, for example, you will get, for example, a 0 in this case. So you can have, if you substitute some values, for example, you will have x of k in this case is going to be, for example, the x at 0, remember, plus this is, we are choosing x at 2, that is the even numbers first, where we have w of 4, 2k, for example. This is even. If you can just make this one an even value, and then you can have the following. So you can have also plus, if you want to add them, you can have w of 4, 1k, of course, into x of 1 plus x of 3. So remember, these are the odd numbers, x of 3. Yeah, and x of 3, w for 2k. Yes, so these are also some values. So if we substitute those values, for example, if we can take these even numbers for k is equal to 0, for example, if it ranges from k equals, in this case, 1, 2, etc., up to n minus 1, then you start substituting k is equal to 0, then throughout you can get the value, and so on and so forth. You substitute even at you can substitute at any number, then you can get your points. So this is where, okay, this is where we are using n, the RADIX-2, using n is equal to 4, for example. So we first of all divide them into even notations to their odd numbers notation. Then you substitute into your values. Then you can get, in the end, the value. The answer is going to be the same. This was showing the relationship, but when you substitute your values beginning to these numbers, still you will obtain this number 1. So those are the resultants in terms of W and so on and so forth. So you can continue for RADIX 2 in the DIFT for n is equal to 4. So for the 4 points, for example, we will also have, of course, it is going to be the same as we have seen. And there is efficient approach of this value. For example, you put it in a matrix format, then you can easily determine by the value of x of x's and the even values and odd values. So for example, if we say, if you have 4-point DFT, and you want to separate each signal by signal. So if you have 4-point, the other one was 4-point DFT. You are using FFT algorithm, of course. You can supply the other ones. But the resultant values that we are supposed to be get, number 1, you remember you are going to get x of 0 plus x of 2. These are the even values, for example. Then you take them out. Then you can put, for example, x of 1, then plus x of 3. You take them out. And this is going to be the function. For example, you say function g1 plus g2. That is the procedure. To make it the simplest approach, you can do one of these procedures. Number 2, you are going to take out, for example, and this is the x0, for example. The x1 in this case is going to be, so you are x at 0, x at 1. So x at 1 is going to be the difference of what you have got from the negative value. Remember, this is a summation, but here we are taking the difference of these values. And this is going to be the summation of at j point. Remember, it used to be having x1 plus x of 3. Yeah. So you get these points at x is equal to 1. And this is nothing. If you want to put into the corresponding function, you say h1 minus j h2. So these are the functions that you can simplify them. And these steps also, you can also calculating out the 4-point DFT also, you can follow these steps. At x is equal to 2, that is 4 points, is going to end up to point number 3. If we are to begin from 0, as we have begun from this side, we can say, for example, at x is 2, is going to be the x of 0, in this case, plus x of 2. We are adding the evens. Values in this case, then minus x of 1 plus x of at 2 in this case. And this is nothing but the difference of these numbers. So you can see only a minus has occupied the space. The rest are the same, G2. Yeah. So at number 4, which is the last point, we are stopping at 3, is going to be the x of 0 minus x of 2, then plus j of x of 1 minus x of 3. So the x of 0, you know its value. The x of 2, you know its value. So j at 2, at these values, suppose if we are using, for example, k values, for example, k equals 0, 1, 2, and 3, because they are 4 points. 4 points, remember. Then you can substitute them in this case. And this case is going to be function h1 plus j h2. So this is going to be the function, it's going to be the function, it's going to be the function, and this is going to be the function in this case. So this is the easiest way. So suppose if you have 4 inputs, 4 points at the inputs, and you have to get the 4 points at the output, then you can get the same layout. That's what I may say. For example, if you have these values, then you can have a very simple layout of what it means. So it is easier for you to know where to begin and which point you are going to calculate first. If they say calculate x at 2, you know that it is this formula. So we are trying to summarize on what we have discussed on RADIX-2 and RADIX-4. And we said that RADIX-2 is 2 inputs and 2 outputs, whereas RADIX-4 is 4 inputs and 4 outputs. So they are similar, only the number of inputs are increasing. And we said from our explanation that the more the number, the RADIX number, the more the efficiency of your computation. I mean, it becomes very nice when it has when the RADIX number is increasing. For example, if you compare the RADIX-2 and RADIX-4, then you can consider only RADIX-4 because the number of radixes have increased. So the rest is almost the same because we are applying the DFT formula. So it is just a matter of just supplying the number of inputs given to any points. If you have 4 inputs, then you can have a similar output. Then if you combine them, then the number increases. So that's what I may summarize on what we have seen on RADIX-4. Remember, it is used for fast Fourier transform. It is trying to pull out the other, the complex multiplication and the complex addition to the symmetric and periodicity or property of the fast Fourier transform. So they have summarized using RADIX, meaning the number of inputs and the number of outputs.